Let's now take a look at the first part of Activity 3, Activity 3.1, which is to make some gear drawings. Now, this first part is really super, super important. You're going to review a standard drawing or what's called a representative sample. And many design shops and engineering offices use representative samples and say, okay, make yours look like this. That doesn't mean copy that one. It means really review that and make sure that you're following that format. So this is a very, very critical part of this next step so that you know what that looks like. Now, you should note that a lot of those values that you're going to see on this one are just, they're variables. They're just placeholders. XX, YY, diameter. That means that you're going to put a value in there based on your specific design. And so you want to, that's why we got that gear data out so that you could have all that information to be able to put in there. Because remember, on this type of a drawing, this is a specific drawing, but it's going to follow a pattern. So let's take a look and see what that pattern looks like. In general, there will be a front view, a section view that will detail what the shaft hole looks like and any other things that aren't just the gear teeth. There's often an isometric view, not always, but sometimes. In this case, it's giving some information about what these holes are for and what these little things are. It's called a corner relief, which you could Google and see, but it means that when you put a hexagon in there that's got a sharp corner, the sharp corner falls into this little hole part and doesn't interfere, so you get your pressure all along the flat. Okay, so there's a front view, a section view, an isometric view. Other things that are always on there are usually something about the gear data. Okay, because it's easier to see the gear data in one place and then just identify what you're talking about on here. Because the gear data, it's going to come that way to you. It's called a gear blank. And you purchase gear blanks of certain face width. And then you do the special stuff that you need. This stuff in the middle and these holes over here. Because gear hobs are very expensive, intricate machines, but boy, do they pop gears out fast. So most manufacturers just buy what's called a gear blank. So this gear data table lets somebody know really quickly what they're looking at. Okay, some other things that are very general on a drawing is that there's a general notes. There's always some sort of notes that just apply that are telling you something other than what's the form, fit, and function of that part. It's usually about what you're going to do with it. A revision history is always important. The ISO and actually any good quality control system says that when you make something, you're supposed to use the most current drawing, unless on purpose you're making a replacement of an old one. So there's some sort of a revision control document that tells people what's the most current one, and you can pull your print and see if it is the most current one. There's the title block that says who you are, what the title of this drawing is, what the file number is. That's the drawing number is usually the file name, how many sheets there are, what the scale is. Now, sometimes the scale is listed over here. Usually there's a scale. You want to know what you're making this from. Okay, so that's called a parts list. And you don't really know. There's only one item on here. And it's one. But what is it made from? And so you would normally put the gear blank part number in here. You're going to walk over to a shelf that's got gear blanks all over it, and you're going to get this thing without all the holes in it. That's called a gear blank. And so the stock number of what they're supposed to get to make this particular part with all this stuff done, you make from a gear blank. And then, of course, there's all sorts of materials that could be thought of. You just make one up for now. I don't really care. Okay, so that's sort of what goes in here. Oh, then there's one other thing. There's your tolerances. So ANSI practices, all engineering drawings must require that all dimensions show the limits of what are acceptable. That's called the tolerances. Okay, so if I see a bolt circle of 0.63, I have to know if 0.625 is okay, or 0.640, or 0.600. I have to know how closely to this number I need to make it. Well, in this case, if it doesn't have anything special put by it, this one's got special. Okay, if there's nothing special, I go to my standard tolerances. And it's got 2 decimal places, so I would read 2 decimal places. And it says I could be plus or minus 0.03. So let me do that. I'm going to see what's acceptable. 0.63 plus 0.03. I could, if it was up to as much as 0.66, I would say this part is good. Or 0.63 minus 0.03, 0.60. So it's 0.600 to 0.66 would be my tolerance. And if somebody were to measure this after it was made, they could compare that plus the tolerances to find out whether the part is good or not. And then there's all sorts of other stuff for you to find out on here. Okay, these are geometric tolerances. Here's a deviation tolerance. And so you just want to see what's on here to see what's normally done. Okay, now this is called a reference because the depth is called out over here. The depth is already called out over here. So that becomes a reference. Okay, so there we go. So that's sort of what you would look at, and you would want to see what this is about. Oh, okay, I see this dimension, so something's going to fit in there, and I got to pay close attention to it. Look, this one says 3 decimal places. So I'd have to do that one 0.875 plus 0.010 minus 0.010 to find out what those limits are. So that's what we do when we look at a drawing. We do our best to figure out as much as we can about it. And then every gear drawing I make is going to look kind of like this. This information will be on there. This information will be on there. This information will be on there. Will be on there. And see, look, I'm leaving it. I'm saying this outside diameter, go look it up in the table, 2.5. The pitch diameter, go look it up in the table, 2.3. Okay? So a lot of this information comes from the table. 6 places here means that there's 6 of these. 1, 2, 3, 4, 5, 6. On a bolt circle, that means that the bolt circle is aligned with the corners. So I'm gonna find where that corner of this hexagon is. And right on that very corner, I'm going to put a diameter 0.09 by 0.625 deep. So on every corner, I'm going to do that. So there's some cool things to think about and see and understand. Don't need too much understanding yet, but you should see the look of it and make sure everything is in there.